let's go. This Python convert into floats once the result is divided. So if we're using floating point division, it will. If we're using integer division, then it won't, right? So here we're using floating point division, integer division. What kind of division am I using here? Floating point. So it's converting them to decimals, which it should, because that's what we had covered, right? So okay, so but yeah, good question there. So now let's go back and what are we doing? Square a value, right? So we're like def let's see here. Thinking. Maybe I name it. I think this will work. I'm not sure. I haven't tried it. I don't code in Python every day, so let's see. Power function. Okay, and we'll say val1, and then we'll say, what's this, exponent, right? And we'll see what we get. So result equals val1, and if we use the double asterisk, and if we use 2, then it squares them. But I'm assuming that if we use 3, it'll cube, right? I'm not sure. I haven't tested this, but that's great. We have code, and we can test it using a test case. Okay, so we have this piece here, and let's create a test case for it. Enter, backspace, def, test, that function self is required. We'll create an assertion, assert equal. Actually, let me stop. Actually, I'll split the other video. Okay, so I'll continue. So assert equal, and then we are trying to test power function, and we will say what values, maybe what did I use here? Look at my test case. Okay, so we will say value 2 to the power of 2. That should give us value 4. Okay. We gotta help recognize power function, so we go here, hover, quick fix, add, and now it should add power function. Let me do something. Let me do this. Enter. Okay, I think what is it? This to split? Yeah, backslash, right? So backslash tells Python these 2 lines are together. I just split them so that it could be easy for me to read. Okay. Okay, so we got this piece, so it's baby steps. So let's test that function first. Let's test this piece, make sure that it's working as I think it works. So we go to run test, run Python. I didn't return a value. Again, enter, return result, run test. So, you know, if you see none, then you're like, oh, I didn't return a value for my function, right? Run it. And we are interested in power function. And so far, I guess that's good, right? So let's go back to the test file. And we're like, well, maybe let's create another assertion. Self dot assert equal, we use this power function, and now we use value 8 squared, and that should be what, 64, right? 64. And we can run it. So run it. Not from here, we have to go to run test. So run test, run. And we are still okay. Power function is here and it's okay, so that works. Okay. So now let's go and create another assertion. So let's go to test input, and maybe here we're like dev test power function cubed, right? And then here squared, I guess. So we say self assertion assert equal our power function, maybe 2 and 2, right? So 2 and 3, so that's what, 2 times 2, 4 times 2, 8. Okay, so hopefully that's the value we get, value 8. Questions here with what we're trying to do? Okay, so let me clear. So we'll go here, clear, run test file, play, and cubed is right here, second to last. So that's good, it works, right? So let's create one more assertion just to make sure. So we're like, okay, let's create one more, self dot assert equal, and we want maybe 3 and 3. So 3 times 3, 9 times 3, 27, right? So 27. Go to run test, and let's see what happens. I'll go here, and we're good so far, so great, right? So at least we are showing arithmetic operations, and at the same time getting more practice with creating functions and testing them and using them in main. Okay, questions here? The longest 15 seconds. Okay, no questions. Okay, so now let's use this code in a main program. So we go here. We can eliminate this piece. Probably this. And we'll need okay, that should be okay. Okay. So again, we are converting them to numbers right away after we collect them. Right, so what do we do? Okay, let's say result, create a variable, and assign it the value from input process dot power function, and we want to use val1 here and val2 here. Maybe here we say exponent. If we do that, then we have to name this one exponent, right? So we want to name variables, give them something meaningful. Enter exponent, and enter value. That should be okay, right? A value. And go back here. Yep. So we collect data, convert them to integer right away. Convert them to integer right away is meaning here they are already numbers. So our function should work, right? If we do not do this piece here, then if we try to run this program, Python's going to tell us that it can't work with alphanumeric values to perform arithmetic operations. So it'll blow up in our face. Okay, so let me go down here, clear, and let's run it. So up here, run. Enter value, so we use, I guess, number 2. Enter exponent, number 2. Value 4, right? So notice here, value 4. Here we can go up arrow, enter, it'll run the program again. And then we can say value 2, or actually value, what is it, value 6, right? I said 8. And exponent 2. 64, and then we can use any other values, right? We can say like value 10, square it, exponent 2, 100. Okay. We do have to run the program every time because the way the program runs, it executes this statement, this one, and this one, and when it gets to here, it's like, oh, I'm done. So then the program exits, right? So that's why we have to run it multiple times. And let's go ahead and run now with the Q piece, right? So clear, run, and we set value 2 cubed should be value 8, and value 3 cubed should be value 27, and maybe value 4 cubed 64, right? So very simple example, but it shows us what we can do with functions, right? We can organize our code, and more importantly, we can reuse. Did we reuse our code so far? Yeah, like we write code in input process output file, and we are using it in our test file. So all this code, we're using it, and then we are reusing it in main. So we're promoting code reuse. In the long run, that means fewer lines of code. And if we are the ones who are maintaining that program, then means less work for us, right? Because we don't have like unnecessary code. Questions here?
Sir, in a real time, when we write a program, we run it one time or we run piece by piece?
Here it's one time, right? I mean, and it's in essence it's just one piece, right? This is just one piece. This is what you'll see in the homework assignments, like write your function, test it, and then in main it'll be one piece. Unless I didn't understand your question, I'm not sure if I did or not.
Like we did from the beginning, can we write everything, then floating, and then the addition, whatever, and then after that we run the program one time?
Oh yeah, I think I understand now what you're saying. Like each of these pieces we're running one time in main, I guess.
Yeah.
But if we had a better way of doing it, then maybe it could just be one program that would run everything, or maybe we could choose what to run. I think that's what you're getting at, right?
Yeah.
So right now it's just one small piece because we're learning. But when we get to conditional statements and loops, then we'll know how to run many functions, but only run certain of those functions. Kind of like a real world program, right? Right now it's just like small pieces, like you said. So that's on purpose because students are learning, right? So.
Okay.
Can you run the test again and use decimals? I'm not sure what'll happen, but we can run it. Let me see here. 2.5 interrupts. Converting them to integers, right? So if I wanted decimals, then I would have to use float here, right? and then convert them here, right? So integer is whole number, float is decimal number, right? But we can try to run it. Let's see, we go here, and 2.5, I guess 2, 6.25. So it understands that lingo too, right? I was more focused on introducing development process and like all different kind of ways you can use whole numbers and decimals, right? But I'm not surprised it works. Python is very flexible like that, right? Very flexible for beginners, right? Like it'll be like, okay, that's what you want me to do. That's what I'm going to do. Okay, let me commit this piece. Actually, I wanted to leave them as integers, right? Because that's what we were doing. But as you saw, you can use them as floats too. Floats are decimal values. Yep. Okay, so commit. Yes. Okay, so